Guys, today we're going to talk about using the division algorithm, and the I can statement we're working on is I can use the standard algorithm to divide whole numbers. And for this lesson, you're going to need this worksheet, so make sure you pick up this companion guide because we are going to go through numbers 1 and 4 together, and then you on your own are going to be responsible for 7, 10, 13, 16, and 17 on your own. So all of this work needs to be done in your composition book on the work side of your WSQ. And if you need to, and you probably will, you might need to go on to the next page to continue your work. But do make sure that you still fold your paper in half, and let's save space and get as many problems as we can on a page neatly. Okay. So here are the steps for using the standard algorithm for division. First you divide, then you multiply, then you subtract, and then bring down. And you're familiar with this, so this shouldn't be super new to you, but for the number one question in your summary is to come up with a mnemonic device for remembering the steps: divide, multiply, subtract, bring down. Kind of like how we use PEMDAS or please excuse my dear Aunt Sally to remember the order of operations. So you're going to come up with your own, and we're going to share those in class. So, okay, here's number 1 and number 4, and I'm actually going to start with number 4 because the divisor is smaller and it's a little easier to deal with. And so I look at this number 6 and I say, well, how many times can 6 go into 4,378 at least once? Yes, it can. So you're going to have a digit over the ones place in your quotient. Can it go in at least 10 times? Well, 6 times 10 is 60. And 60 can definitely go into 4,378. And then I'll ask myself, can it go in 100 times? Well, 6 times 100 is 600. 600 can definitely go into 4,378, so we will have a digit over the hundreds place as well. But can it go in 1,000 times? Well, 6 times 1,000 is 6,000, and that is way bigger than 4,000, so we aren't going to have a digit in our quotient in the thousands place. So here we go. 6 can't go into 4, but it can go into 43. So how many times? Let's divide 43 by 6. Well, 43 can go into 6 at 7 times. That's my divide. Now I multiply 7 times 6. Step 2, multiply. 7 times 6 is 42. Step 3, I subtract 43 minus 42, which is 1. And my final step is to bring down. And I keep doing this until I run out of digits to bring down. All right, my next question I'm going to ask myself is, how many times does 6 go into 17, or what is 17 divided by 6? Well, 6 can go into 17 2 full times. 2 times 6 is 12. I multiply 2 times 6. Now I subtract 17 minus 12, and I get 5. That was step 3. And finally, I bring down my 8. Okay. I go back up to the beginning of my of this whole process again. How many times does 6 go into 58? Well, it can go in 9 times. 6 times 9 is 54. I subtract. I get 4. In this case, I'm going to have a remainder. And what I want you to do for remainders is write them as a fraction. So I have 4 left over out of the 6 I need to go in another full time, which will need to be simplified. And I will get a quotient of 729 and 2/3. There is my quotient. Okay, so instead of writing remainder 4, I'm going to take that remainder and turn it into a fraction. Okay. So notice I put 1 digit per square, just like we've been practicing on our Throwback Thursdays, to keep those place values nice and lined up, and I don't forget to bring down a number, or I don't shift my subtraction. And so I can be as accurate as possible. I'm trying to solve these problems. Okay, let's go back to number 1. Again, I asked myself, can 43 go into 1,241 at least once? Yeah. It can go in more than just once. Can 43 go in at least 10 times? Well, 43 times 10, I just put a 43 and I put a 0 at the end. So, can 430 go into 1,241? It can. So I'm going to have a digit over the tens place. Can 43 go in 100 times? So 43 times 100 just means I'm going to take 43, because 1 times 43 is 43, and I add 2 zeros to the end. Can 4,300 go into 1,240? No, it can't. So I will not have a digit over the hundreds place, and then if there's no digit over the hundreds place, there can't be one over the thousands place either. So now I start my dividing. 43 can't go into 1, it can't go into 2, but it can go into 124. How many times do you think 43 can go into 124? Well, let's think about it. If I estimate and say 40 times 3 will give me 120, but 43 times 3 is going to give me probably more than 124, because 3 times 3 is 9, 3 times 4 is 12, so 129 is what I need. So really, 43 can only go in 2 times. 2 times 43 is 86. And when I subtract, I'm going to need to do some borrowing here. I get 38. 38 is smaller than 43, so I know that 2 is the biggest possible number I could have put over the tens place here. Okay, so I divided, I multiplied, I subtract. Now I need to bring down this 1. So I ask myself, how many times can 43 go into 381? And when I do this, I look at my first number, that's a 4, and I round that. Okay, that's close to 40. How many times can 40 go into 380? Or how many times can 4 go into 38? I'm going to guess that's about 8 times. Let's see. 8 times 3 is 24. 8 times 4 is 32, plus another 2 is 34. Now let's subtract and see if that's a good number to use. So I'm going to have to, again, borrow here. And I get a number that is less than 43, so I know I've gone as far as I can. It is also my remainder, so I'm going to put 37 over 43, which cannot be simplified. Those are both prime numbers, so that's as low as it can go. And my answer is now 28 and 37 over 43. Okay, so now it's your turn. Go on back. We've done 1 and 4 together. In the work section of your WSQ, do 7, 10, 13, 16, and 17. And don't forget to WSQ in your notes. You can go back and watch any portion of this video as many times as you need to, or the whole thing. But don't forget that question at the end. That's the most important part.